Hey guys, welcome to week 9 of medical math. Hope you guys are doing okay. Hope you guys felt pretty comfortable with the quiz today. Sorry I couldn't be there today, but hopefully these videos help you guys as we get through the last couple chapters that we're going to cover in the book. Today we're covering chapter 15 and part of chapter 16. So we'll have a couple videos just to go over those two lessons. So in chapter 15, if you're following along in your book, this starts on page 413, and we're looking at intravenous calculations here. So we're looking at IVs. The very first part of the chapter, it goes over some of the basics as far as what you need to know about IVs. As you guys are probably familiar with IVs, we know how IVs work. They are filled with a particular fluid, and then run through a tube and go into a patient through a vein, but are stuck into a patient to deliver that medication directly to their bloodstream. So the first part of this chapter goes over kind of that process and the equipment that's used in that process, some of the terms you may see as you're looking at these types of pumps. If you're flipping through the chapter, you guys can see what I'm talking about. They give you some pictures of the different types of pumps and such that are used in IV administration. My focus as your math teacher, I want you guys to be comfortable with how to calculate things pertaining to IVs. So actually calculating different flow rates actually starts in your book on page 425. So again, the first part of the chapter just introduces you to the equipment and to the main things you need to know about IVs, but you all will learn more about that stuff in your nursing classes. I want you guys to see the numbers. So this chapter, and the way that your book shows it, it's kind of all over the place, but this chapter is focused on what we're doing is calculating different, as far as flows are concerned, we can calculate what's called a flow rate, which a flow rate is exactly how many milliliters per hour a patient's going to get a certain medication. So flow rate you guys will see as milliliters/hour or milliliters per hour. We're also going to calculate how many drops per minute, to a T, exactly how many drops per minute a patient is going to receive a certain IV. So you may see drops per minute because the abbreviation for drops is GTTS, so you may see drops per minute labeled that way. We're also going to be able to calculate a couple other formulas towards the end of the chapter, exactly how many milliliters a patient's going to get based on what their flow rate is. Again, we know their flow rate is milliliters per hour, so if we know their flow rate, in other words, what they're getting each hour, and we know how long an IV should take, we should be able to calculate their total volume. So we'll be able to calculate total volume today. We'll also be able to calculate how long an IV will take. If I'm given, the total volume, how much, they need to receive, and I'm given the flow rate, meaning how much they're going to receive per hour, then from that, I should be able to calculate the time. So we're going to focus on 4 different formulas today. Drops per minute, then we'll look at flow rate, then we'll look at time, and then we'll look at total volume. And we use different formulas for each of these. All these formulas will be provided for you guys. But they are formulas I do think you all need to make yourselves familiar with as you guys go through your next couple quarters at ATA, because you all will get a lot of questions about IVs, and you are not going to be handed those formulas. For the purpose of, for medical math class, because this is the first time you're seeing the formulas, because the final is next week, I'm not going to make you memorize those right off, but I do want you guys to be familiar with these as we go through them. So again, we're going to start with those drops per minute. So I'm going to start with that one first, just because the other 3 all kind of relate to one another. So we're going to start with that one first. So let me just erase all this stuff on here. Okay. So we're going to take a look at that drops per minute first. So how we calculate, again, GTTS is drops per minute. So there's a particular formula, and we can figure this out based on some of the things that are given to us in these types of questions. The formula looks like this. What I can do is I can take my total volume, so my what's going to be given to us is a volume. that volume should be measured in milliliters. Okay, if it's not measured in milliliters, we need to get it to milliliters, meaning that if anything else, it may be given in liters, and we know based on our metrics chapter, we remember how to convert liters to milliliters. If you guys aren't familiar with that, I'll show you guys that real quick. Remember this chart? Kiss hairy dogs but drink chocolate milk mom chart, or your stair step. If for any reason a volume is given as, say, 2 liters, I know how to convert that to milliliters because here's my base, that's liters on my chart, and I'm trying to convert it to the prefix milli. So if we're moving on our chart, that's 1, 2, 3 movements to the right. So with the whole number 2, taking that decimal and moving it 3 places to the right would convert it to 2,000. So that's just an example of, converting liters to milliliters if we needed to. Okay, so let me get this out of the way here. All right, so it's not going to let me get this out of the way. So let me just rewrite that formula up here, what we started with. Okay, so we're trying to calculate drops. Well, that is supposed to be a G. Drops per minute. And again, what we need is the total volume measured in milliliters. If it's in anything else, we can get it to milliliters. And what we're going to do is we're going to divide that by our time, and I'm just going to write T for time. As it's showing you there on page 425, that yellow box on that page is showing us what these abbreviations are for. T is time, but the unit that I need that to be in, since we're trying to calculate drops per minute, must be in minutes. So a quick reminder on that one, if for any reason our time is given as anything else, which for the most part IVs are given in hours, not in minutes, because IVs are usually given over a long period of time. So if for any reason our time is given in hours and we need to get that to minutes, one quick way to do that is to remember, well, there are 60 minutes in an hour. So I know that if I have 1 hour, that's the same thing as 60 minutes. If I have 2 hours, that's the same thing as 120 minutes. 3 hours would be the same thing as 180, and so on and so forth. So the way to get hours to minutes, if for any reason it says to give a certain IV over the course of 4 hours, well, to get that to minutes, all I have to do is multiply it by those 60 minutes, and 4 times 60 is 240. So that's a quick way to convert hours to minutes. So if you need to make a note to yourself that if for any reason this is in hours, make sure you get it to minutes by multiplying by 60. Just remember times 60. If it's given as minutes, then we don't need to worry about that. That's okay. So that's not a big deal. But let's see. Let's go back over here. Go back up to that formula. On this formula, then, what's going to happen is to complete this formula, once we've taken our volume and divided by our time, we're going to multiply it by what's called a drop factor. And the drop factor is always going to be given to us. That drop factor, the units, and it's given, so there's no conversion or anything, but is drops per milliliter. It's called a drops per milliliter infusion rate. So we'll be given 3 things in these types of problems. We're going to be given a total volume, we're going to be given a time, and we're going to be given that drop factor. So some practice problems for this section, for the drops per minute, if you guys actually take a look at page 432, I know that's kind of skipping ahead a little bit, but 432 is going to show us some of these questions. In fact, down at the bottom, it says for exercises 21 and 22, down towards the bottom of page 432, here's how these questions will look. Again, just as a kind of a side note, just to put this back up here to show us what that formula should look like, drops per minute is going to be the volume in milliliters divided by the time in minutes, and then we need to multiply by the drop factor, and I'll just call it DF, drop factor. Okay, so looking at number 21, it shows that, okay, here's what's been ordered. 1,000 milliliters of D5W. First of all, pay no attention to the D5W. I meant to mention that to you guys earlier. That 5 in there has nothing to do with our calculations. A lot of people ask me about things like that. D5W is simply just the liquid that's in the IV bag. That particular abbreviation stands for 5% dextrose water. And so it's not going to have anything to do with our calculation. It's simply just what's in that IV. So there's our total volume. We need to get 1,000 milliliters of D5W over 9 hours using an electronic controller set in drops per minute. Tubing calibration is 15 drops per milliliter. Okay, so there's our three parts. We're given our total volume. Okay, so our total volume, again, is 1,000 milliliters. Okay, so our total volume, is it in the appropriate unit? It needs to be in milliliters. Is it in milliliters? Absolutely. So I don't need to do anything to that. I'm going to leave it as is. But what I'm going to do is I'm going to take it and divide it by the time. And so the time that they gave us in number 21 was 9 hours. So 9 hours here, if I look at that, is it in the right unit? So just pointing this out here. No, absolutely not. It's in hours, so I need to convert it to minutes. So what I'm going to do just real quickly is multiply my hours times 60 again. And so what that's going to do, 9 times 60 is going to give us 540. So that's what I'm going to use in place of my 9 in this particular problem. So I'll just move that out of the way so you guys can see what we're going to divide by. It's going to end up being 1,000 divided by 540. From there, we just need to multiply it by our drop factor, and our drop factor again was just given to us in number 21 as 15 drops per milliliter. That's our calibration. And again, like I said, that's always going to be given in the right units, 15 drops per milliliter. So that's our drop factor. So to complete this problem, all we have to do is take 1,000 and divide it by, let's do this, I'm going to do this with you guys, 1,000 divided by 540, which is going to give us some long decimal, 1.85185,185. And then, but I take that number and multiply it by 15, and it gives us, in my calculator here, it gives me 27.77 repeating, so I'll just round that off to 0.78, just to kind of show you guys. So this is our correct answer. I will mention to you all that drops are typically kind of hard to regulate the size of a drop. You can't give 0.78 of a drop. So for the most part, most drops are rounded off to the nearest whole number. So we would call this about 28 drops per minute. But if you gave me 27.78 or 27.8 or 27.7 on the final, am I going to mark you wrong? Absolutely not. That is still a correct answer. I know that you did the calculation right, and that is my main concern, is that you're doing the calculation correctly. Okay, so just looking at another one, let's take a look at, let's see, I wish I could erase this a little bit easier. All right, so looking at the next one, number 22, it's a very similar problem, but just a few different numbers. It says ordered is 750 milliliters RL over 8 hours by an electronic rate controller set in drops per minute. Tubing calibration is 15 drops per milliliter. Okay, perfect. So what we're looking at here, our total volume is 750 milliliters. So it was given to us. Is it in the correct unit? Yes. I don't need to do anything to it. I need to divide it by the time. The time in number 22 says 8 hours. So what I'm going to have to do is take 8 times 60, just like we did in the previous problem, because I need my time to be in minutes. So when I do that, 8 times 60 gives me 480 minutes. So that's the number I'm going to use here in this problem. And then I'll multiply by the drop factor. In number 22, the drop factor was 15. So to complete this problem, I'll just do what's on the screen there, 750 divided by 480, and then I take that and multiply it by 15, and it gives me about 23.4375 is what my calculator is showing me. So I would say that's about 23 drops per minute as my answer. But once again, if you gave me 23.4, I would still mark that as a correct answer. Okay. So those are some examples with drops per minute, and so that's the formula for that one. And that one's kind of our unique formula in this chapter because it does utilize a drop factor, and it's also the only formula where the time is going to need to be in minutes. Everything else from this point forward in the next 3 formulas in this chapter we'll be using hours. So looking at the next one is the flow rate. And I had mentioned to you guys at the beginning that the flow rate, or I'll just say F for flow rate, is the same thing as milliliters per hour. So a little bit different than our previous formula. Our previous formula, we were looking at drops, so a very small amount, how many exact drops per minute each patient is getting per minute. But here I'm looking at the total, not total volume, but the total amount of milliliters that they're getting over the course of an hour. So we should be looking for only two things, and these two things are right here. These are the, this is what flow rate is milliliters per hour. So what we're looking for in order to calculate this is going to be a total volume. Again, my volume must be in milliliters. And I'm going to divide it by my time. In this case, as that, it tells me up at the top, my time in this case must be hours. So once again, if it's given in anything else besides milliliters, more than likely you're just going to see liters. And so all you're going to have to do is remember 3 decimal places to the right, or times 1,000 for those of you guys using the stair step, in order to get it into milliliters. For the time though, it's rare, but every once in a while you may see the time given to you in minutes, but you need it in hours. So opposite of what we just talked about on the previous formula, if for any reason the time is given in minutes, in order to get it to hours, we're going to have to do the opposite of what we did previously. Remember in our drops per minute formula, I had told you guys, in order to get from hours to minutes, on the last one, I told you guys that you all just had to remember times 60. Well, then how do you think we're going to go from minutes to hours if I'm given minutes and need to convert it? For those of you guys who are saying divide by 60, you're correct, because we're doing the opposite. So that's what we'll have to do if for any reason our time is given in minutes in this particular case. So I'll show you guys an example with those. So again, we're just looking for two things. I'm looking for volume and I'm looking for time. So my total volume and my time, and then we just divide the two. So some examples of this, if we're still on page 432, there's a couple examples of this. Actually, those are just looking at the labels there. Actually, take a look at the previous page, page 431. On page 431, looking at numbers 1 through 4, these are some great examples of flow rate problems. It says to calculate the flow rate in milliliters per hour. So prime example there, number 1, it says to give 1,000 milliliters of LR over 6 hours. And so again, all we need is milliliters divided by our time, so our hours. Well, that's a horrible looking hour, but that's what that's supposed to say. So in this case, we're just taking 1,000 milliliters over the time that they gave us was 6 hours. Are both in the appropriate units? Milliliters and hours? Absolutely. So all I have to do is divide the two. And when I divide the two, it's going to tell me exactly how many milliliters that patient's going to get per 1 hour instead of 6. They get 1,000 over 6 hours. When I take 1,000 divided by 6, I get 166.66666 repeating. And so I'll just round that off to 0.67, or if you round that off to 0.7, or it really doesn't matter. As long as you get something close to this figure, that's correct. Milliliters can be regulated by decimals, so if you leave the decimal in there, that's appropriate in this case. But that's what we get. That's how much they would get per hour. So doing a very similar example on that same page, just moving down to number 2. Number 2 says 300 milliliters of NS over 2 hours. So I see that they're going to get 300 milliliters over 2 hours, but I want to know what that means per 1 hour. And so some of you guys may be able to just, if you think about this, you could probably just do it in your head. If they're getting 300 milliliters in 2 hours, then they're only going to get half of that in 1 hour. And so that's exactly right. We're taking 300 milliliters, that's our total volume, over our total time, which is 2 hours. And when we take 300 divided by 2, that's correct. They're only going to get 150 milliliters per each hour. Let's see. So same thing with number 3. They just use a medical abbreviation. They say 3,000 milliliters of 1/2 NS, which is just half normal saline. Again, pay no attention to what's in the IV bag. I just need that total volume, 3,000 milliliters. And it says to give it over 24 hours. That's just the abbreviation for that. So I'm going to divide by 24 hours. And 3,000 divided by 24 is 125. So that's what they get each hour. Number 4 is the great example of where we would see some minutes instead. So let me show you how we can do that conversion there. Number 4 says what's ordered is 40 milliequivalents KCl, or potassium chloride. No need to worry about that. That's just the dosage. But it says the dosage is in, whoops, I don't know what that is. Sorry about that. Not the dosage, but the amount of volume that we need is 100 milliliters over the course of 45 minutes. So in this case, it's just a short IV. Their total volume isn't very much, so that's why it's only given over 45 minutes. However, in order to calculate the flow rate, I need milliliters per hour. So what I have to do is I'm going to have to convert that 45 minutes to hours in order to complete this problem. And as I mentioned at the very beginning, in order to convert minutes to hours, all I have to do is divide by 60. And if we did that in our calculator, 45 divided by 60 gives me 0.75. It's only 0.75 hours. So I'll use that in place of my problem here. And so if we're receiving 100 milliliters over 0.75 hours, when I divide 100 divided by 0.75, they would receive 133.3 milliliters in a full hour. And that would be their flow rate, 133.3 milliliters per hour. Another example that might be a little bit easier as far as that is concerned with minutes, if I were told that I need to administer 100 milliliters over 30 minutes, a very, very similar example, except sometimes 30 minutes is a little bit easier for us to see. They are to receive 100 milliliters in a half an hour. I want to know what they're going to get in a full hour. That's what the flow rate is. In my head, I can say, well, if they're receiving 100 milliliters in 30 minutes, well, that's going to be 200 milliliters in a full hour. It's going to be double that. And that's correct. But the way we can put that into our formula, if we're not doing it in our head, is to take our total volume again and divide it by hours. 30 minutes is not in hours. So 30 divided by 60 gives us 0.5. We know 30 is half an hour, or 0.5. So that's what I can use in my problem here in place of that. So I'm going to take 100 and divide it by 0.5, and you'll see that the answer they give you is 200. They get 200 milliliters per hour as the flow rate. So that's what you would use there as far as flow rate goes. You just need milliliters, and then you just divide that by your hours. Okay. So that's your flow rate. The last two formulas that we're looking at are very, very similar to that flow rate formula. Our flow rate formula again was F is equal to milliliters divided by hours. Well, the next formula that we're going to look at is what if I'm only given my total volume, but also given my flow rate? From there, I should be able to figure out how long that's going to take. And if you think about that, given a particular scenario, let's say one that's a little bit easier. Let's say a patient needs to receive 200 milliliters total with a flow rate. So their flow rate that's been given is, let's say, 100 milliliters per hour. I'll write that out here, 100 milliliters per hour. If these two bits of information are given to us, let's think about this logically. They need a total of 200 milliliters, but they're getting 100 milliliters each hour. Well, how long is that going to take? For those of you guys that said 2 hours, you're right. They're getting 100 milliliters in 1 hour. They're going to get another 100 milliliters in the second hour, therefore giving them that total volume in only 2 hours. But the way that we can calculate that is through this formula. Our formula for this one is just slightly different. It's just that flow rate formula rearranged. It says to calculate the total time, we just need our total volume in milliliters. And I'm going to divide that by our flow rate. And again, our flow rate is milliliters per hour. Is milliliters per hour. So what's going to happen here is your book has showed you probably a couple times that what happens when you have similar units as numerator, denominator, what happens is they end up canceling each other out, leaving me with the only unit left over is hours. So that's going to tell me how long this is going to take. So in that previous example I just gave you, the person was supposed to receive 200 milliliters with a flow rate of 100 milliliters per hour. So sticking that into our formula here and performing our calculation, we know that 200 divided by 100 is absolutely 2. That's only going to take 2 hours in order for them to receive that total IV. Looking at some example problems in your book, I've lost my bookmark here. There it is. On page 437, there's some review and practice problems down there at the bottom. So in calculating the time, I'll put the formula back up here. We need volume over flow rate in order to solve this formula here. That's supposed to say per hour. So looking at one like on the bottom page 437, number 1 says, in this section says define the time. So it says what's ordered is 1,000 milliliters normal saline at 83 milliliters per hour using an infusion pump. From there, we need to figure out how long that's going to take. And again, in just plugging that into the formula, our total volume in that question is 1,000 milliliters. It's in the right unit I need it to be in. And I divide it by the flow rate, which is 83 milliliters per hour. So given that bit of information, I should be able to figure out how long this IV is going to take to administer to this patient. I just take 1,000 divided by 83, and that gives me 12.04, which is about 12 hours. For those of you guys that are curious as far as what 12.04 means, if you guys on a test, if you all just told me 12.04, which it looks like, according to this, it looks like it's closer to 12.05 if we're rounding correctly. What does that mean in terms of hours and minutes? We know that time isn't measured in decimals, which that may be something that comes up a little bit later on in later nursing classes. Right now, on a final, if you gave me 12.04 or 12.05, or if you just said, hey, that's about 12 hours, then I'm good with that because I know you did the calculation correctly, and that's all that matters to me. But if you're curious as to what 05 means, we know that 12.05 means that I'm going to get this over 12 hours, but 05 is where I'm going to get my minutes, and it's not 5 minutes. What actually that means, if we think about decimals, for a brief second, think about what this decimal means in terms of a fraction. We did that earlier on in class. We used a chart. If you guys recall the decimal fraction percent ratio chart that we used on the midterm, we know that 0.05 is actually the same thing as 5 over 100 in terms of a fraction. It's 5/100ths if you say it out loud, if that's how that would be read. And remember, we did that because we moved our decimal point 2 places to the right to get it to the end, to turn it into 5. And then because I moved 2 decimal places, my denominator has 2 zeros in it. So since 0.05 means 5 over 100, I want to know what it means in terms of minutes. So I want to know what it is out of 60. So what I could do is, just set that equal to x over 60, going back to our proportions that we talked about earlier on. If I know that 0.05 means 5 over 100, this proportion is asking me then what does that mean over 60? Remember, proportions are read like analogies, and we're saying 5 is to 100, as then what is to 60? So we can use our proportion here to, our skills, remember we cross-multiplied opposite of the x. We took 60 times 5, which is going to give us 300, and then taking that number and dividing it by 100, that gives us 3. 300 divided by 100 is 3, which means this IV is going to take about 12 hours and 3 minutes. That's what that 0.05 actually means. But like I said, for my final, you all do not have to tell me that, all that information. But that may be helpful later down the road. So hang on to this video as you guys start getting into your NPN and your pharmacology classes and such. But going ahead and taking a look at another one, number 2 says to administer, or what's ordered is 500 milliliters at 125 milliliters per hour. So there's my flow rate there. So that's what they're going to get total and that's going to be their rate of the flow. So if I take 500 divided by 125, that's going to take about 4 hours. It gives me an even 4. So that's how we calculate that. In order to calculate the time, I just need to take my total volume. Oops. Oh, sorry. I'm doing something weird here. I need to take my total volume and divide it by my flow rate. And then finally, the last formula that needs to be completed here is we can calculate how much total volume is going to be administered if I'm given the time and the flow rate. So a prime example of this case here, if I said that a patient needs to receive an IV at a flow rate of 100 milliliters per hour. Okay, so that's the flow rate. That's what they're getting each hour over the course of, so let's say over 5 hours. From that information, could I figure out exactly how much they're going to receive after that 5 hours? Absolutely. They're getting 100 milliliters each hour. And then since they're doing that, they have to receive that IV over 5 hours. It means they're doing that 5 times. So they get 100 milliliters, 100 milliliters, 100 milliliters, 100 milliliters, 100 milliliters, giving you a total of 500 milliliters. So you guys are going to see what's going to happen here. To calculate the total volume, I need a flow rate. So my flow rate again is milliliters per hour. And what I'm going to end up doing is just multiplying it by how long that's going to take, the time in hours. So that's our formula for total volume. As you can see, it's still that flow rate formula, just rearranged. We're still using the same 3 things, a volume, a time, and a flow rate. But the last 3 formulas we've looked at today, we've just rearranged them. So again, in all 4 formulas that you've seen in this video today will all be provided for you. So it's just going to be a matter of plugging them in to that appropriate formula. So let's look at some example problems for that total volume. If you flip over to page 438, you guys can see numbers 11 through 14 are asking us for the total volume to administer. So I'm going to go ahead and take a look at the first one. Number 11 says that we need to give an IV at 75 milliliters per hour, so there's the flow rate, of 1/2 normal saline for 2 hours and 30 minutes. So this one, and I'll tell you guys too, I'm not going to give you guys minutes, but if I did, it may be something just as easy as this, because we know 2 hours and 30 minutes is actually the same thing as 2.5 hours, or in other words, what I'd multiply by is 2.5 hours. Okay, because I need to incorporate the entire amount of time. So from that information, I should be able to figure out exactly how much they're going to receive. If I take 75 times 2.5, they're going to get only 187.5 milliliters over the course of that IV. Another one that might be a little bit easier is the next one as we move down to number 12. Number 12 says D5RL set at 100 milliliters per hour. So there's my flow rate, 100 milliliters per hour. And again, I'm just plugging it in to our formula for volume, which says to take my flow rate and multiply it by my time. And in number 12, it says for 8 hours. So I'm going to multiply it by that time. And all I have to do is take 100 times 8. They're going to receive a total of 800 milliliters in this case. So you can see kind of similar fashion is going to take place in number 13, D5W at 125 milliliters per hour for 12 hours. So I just take 125 times 12. They get 1,500 milliliters. And then down in number 14, the antibiotic solution infused over 2 hours at 75 milliliters per hour. It would just be 2 times 75 to get 150 total milliliters. So in just kind of wrapping up, that's all of chapter, what chapter is this again? Chapter 15 that I wanted to show you guys. So today, again, what we've looked at 3 different formulas. We've looked at our drops per minute. And again, like I said, drops per minute, as you guys remember, was our only kind of unique formula in that we did need a volume in milliliters. It's the only formula that uses our time as minutes, and then it's the formula that incorporates a drop factor, or drops per milliliter. Everything else is pretty much the same formula rearranged, but you'll have all of these formulas provided for you guys. Remember, flow rate is volume over time, but it's milliliters divided by hours. The total time, if you're calculating the total time, you take your total volume that's given to you and you divide it by the flow rate, which will also be given to you. And then if I need to calculate the total volume, the last one we did, we'll be given a flow rate, which is milliliters per hour. Sorry, that handwriting's so sloppy. And we just need to multiply it by the time as hours. So you'll have all four of these formulas, and the way that they'll be worded on the test, I will give you these questions and ask for the appropriate, I'll have them in order for you guys, and each question will ask for either drops per minute, flow rate, time, or volume. So you don't have to try and guess which formula you're supposed to use. It'll be pretty self-explanatory on the test. But then all you guys have to do is just plug those into the appropriate places, making sure that they're in the correct units. That's a big thing I see is sometimes people forget to change the hours to minutes, or sometimes forget to change the liters to milliliters if need be. But as long as we're plugging them into the appropriate place, using the correct units, you guys should be good. So that's all for Chapter 15. I hope that's okay. If you guys have any questions, please, please, please don't hesitate to email me and let me know. Thanks, guys.